Refrigeration seal system repairs procedure. Step 1. Arrange all the tools and equipments necessary for repairs. Place the refrigerator under repairs in an open, well-ventilated area. Remove drain pan from top of compressor. Step 2. Reconfirm defect after running the refrigerator when possible. Use piercing valves to check system pressure and confirm system defects or compressor efficiency. Connect piercing valves to process lines on compressor and dryer. Connect hoses to piercing valves and other end of hoses to a manifold with compound and pressure gauges. Open the piercing valves and observe system pressures in idle condition. Run the compressor wherever possible and check compressor efficiency and system defects. In this system under repairs, compressor needs replacement. Step 3. Recovering or venting of refrigerant in the system. Recover CFC or HFC refrigerant from the refrigerator using a recovery unit and bag or cylinder, as they are not environment friendly. Disconnect system from manifold after closing the piercing valves. Connect system to a recovery unit. Connect inlet of recovery unit to piercing valve on the compressor process line and outlet to a recovery bag or cylinder. Open the piercing valve and observe system pressures on compound gauge of recovery unit. Run the recovery unit and collect refrigerant into the bag or cylinder. Observe rise in pressure on the pressure gauge attached to the recovery unit. At the same time, observe drop in pressure on compound gauge of recovery unit. The low pressure cutout attached to recovery unit stops recovery process as the pressure inside the system drops below the LP cutout limit. Care to be taken not to allow system pressure to drop to vacuum level. Once recovery is complete, close the piercing valve and detach recovery unit from the system. Remove the piercing valve. The system is now ready for debrazing. For hydrocarbon-based systems, HC refrigerant being environment friendly can be vented out in atmosphere. Disconnect system from manifold after closing the piercing valves. Connect a long hose to piercing valve on process line. Place the other end of hose in a safe, well-ventilated place outside work area. Open the piercing valve and vent out refrigerant. Once maximum refrigerant has been vented out, close the piercing valve and take out the long hose. Connect the system to a vacuum pump and remove the entire residual refrigerant by running the pump for a few minutes. This is part of safe servicing practice, as hydrocarbons are flammable gases. Hence need to be totally removed from system before debrazing of joints. Close the piercing valve and detach the pump. As the system is under vacuum, use nitrogen pressure to break vacuum before removing the piercing valve. Open the piercing valve and let in nitrogen pressure, just enough to break the vacuum. This is a good servicing practice, as atmospheric air will enter the system if piercing valve is removed without breaking vacuum. Remove piercing valve and let out the nitrogen. The system is now ready for debrazing. Step 4. Debrazing of compressor and system joints. Cut and remove process tube ends and capillary from dryer outlet using a capillary cutter. Remove all electrical connections from compressor. Keep heat deflector plates under joints to avoid damage to refrigerator base or other parts. Also, it helps for faster heating when using air LPG torch. Set up brazing torch, either air LPG or oxyacetylene. Debraze all compressor joints as compressor needs to be replaced and dryer joint. Use wire brush and clean joints of all residual filler material. Step 5. Replacement of system components. Remove compressor mounting clips and take out compressor. Also, it is very important to replace dryer as and when system is processed. Step 6. Polishing and flushing of tube ends. All tube ends of components like compressor, condenser, etc. need to be polished using emery cloth paper for cleaning the surface of rust, paint, etc. before brazing. Components like condenser and evaporator need to be flushed with nitrogen at 65 psig or 4.5 bar pressure to flush out all contaminants like moisture, oil, non-condensable gases, etc. from inside the tubes. Use male-female coupler for quick operations and ease of fitting. Connect the male coupler or process valve to condenser inlet. Insert nitrogen through the male coupler, block the other end with thumb and build up pressure. Release thumb when pressure has built up sufficiently. Repeat this for thorough flushing. Evaporator to be flushed after detaching capillary from it. This will prevent oil entering the capillary and also helps for faster flushing. In case of excess contamination needing chemical flushing, use trichloroethylene as use of CTC is banned due to environmental reasons. Step 7. Brazing of joints. Place new compressor on base plate and secure with locking clips. Refit all tube ends to compressor. Attach process line to compressor and all compressor joints. It may be necessary to switch the process tube end before connecting it to compressor charging tube. Swedging process. A process used for joining of two copper tubes of the same diameter by expanding the end of one tube to fit over the other. A flaring block, correct size swedging punch and hammer are the tools required to carry out the process. Procedure for swedging. Place the tube to be swedged in a flaring block that has a hole equal to the size of the outer diameter of the tube. The tube should extend above the block approximately the length of punch, tapered portion only to be used. Place the punch in the tube and strike it with a hammer until proper shape and length of the joint has been obtained. A drop or two of refrigerant oil on the punch will help during swedging but should be wiped off before brazing. Assemble the tubes. It should fit easily. Inspect tubing after swedging for cracks and other defects. If any seen, cut off and redo. Flaring process. When a tube has to be connected to a fitting with help of flare nut, the tube end is flared. A flaring block and yoke are the tools required to carry out the process. Procedure for flaring. Cut the tube to be flared to the right length. Ream the cut end to remove all burrs. Insert the flare nut over the tube with the threaded end facing the tube end to be flared. Place the tube to be flared in a flaring block that has a hole equal to the size of the outer diameter of the tube. The tube should extend above the block by approximately 3 mm. Place the yoke on the block with a tapered cone over the end of tube. Twist the yoke for proper grip on block. A drop or two of refrigerant oil on the tapered cone will help during flaring. Turn the screw on yoke down firmly. Continue until flare is completed. Unscrew the yoke fully and remove from block. Inspect the flare for defect. If any seen, cut off and redo. Remove tube from the block. Check for proper fitment of flare nut. Keep heat deflector plates under joints to avoid damage to refrigerator base or other parts. Also, it helps for faster heating when using air LPG torch. Set a brazing torch, either air LPG or oxyacetylene. Braze all compressor joints using suitable filler rod and flux. Cuporectic rod for copper to copper and silver brazing rod for copper to steel joints. Pass nitrogen through process line and check for flow through condenser end and capillary. Attach new suitable dryer to condenser end with process line and capillary to dryer outlet. HFC 134A systems require special dryer with high moisture absorbing capacity. Keep the compressor process tube end open. Braze dryer joints. Brush all joints with wire brush to remove flux residues. Step 8. Choke and leak testing. Connect couplers or process valves to process tubes of system. Set nitrogen pressure to 150 psig or 10 bar. Insert nitrogen into the system through the high side process valve and check for flow through the process valve at low side. Reverse the process and check. If flow is normal on both sides, it shows that the joints are free of any restrictions or choke. Keeping the same nitrogen pressure in the system, check all joints for leak using soap solution. Clean soap solutions from joints after confirming no leak. Step 9. Fixing back electrical accessories. Fix relay, OLP etc. onto compressor. Ensure proper fitment of relay cover. Step 10. Evacuation. Set up evacuation and gas charging unit. Release nitrogen from the system from high side first and then low side of system. Connect system process lines to manifold on evacuation and charging unit. Run the vacuum pump on evacuation and charging unit and open the valves on manifold gradually. Connect a thermocouple vacuum meter to evacuation and charging unit for measuring vacuum. Observe drop in reading on thermocouple vacuum meter indicating vacuum level in the system. Continue to evacuate till readings are around 500 microns. Conduct pressurized test or vacuum holding test and confirm proper evacuation. Step 11. Gas charging. Set up refrigerant cylinder on a weighing scale. In case of blends, it has to be taken out from a cylinder in liquid conditions only. Ensure that the system compressor is off while gas charging. Place the refrigerant can with adapter inverted on the stand and place the stand on the weighing scale. Connect a charging tube to the adapter on can and the other end of tube to the evacuation and charging unit. It's a good servicing practice to evacuate the charging tube before filling it with refrigerant. Avoid purging of tube. Weigh the assembly and tear the scale. Open the charging valve on evacuation and charging unit and note the reading on weighing scale. Charge the mentioned quantity of refrigerant. Refer label on appliance. Close the charging valve on evacuation and charging unit once the desired quantity is charged into the system. Disconnect the vacuum hose from high side of system once gas charging process has begun. Gas charging can be done by two methods, by weight and by volume. By weight is the most accurate method as weight remains same at any atmospheric temperature, whereas volume varies as per change in temperature. Step 12. Performance testing. After gas charging, wait for 2-3 minutes before switching on the refrigerator. During this period, it's a good servicing practice to check for leak on all low side joints of the system. Once the refrigerator is switched on, let it run for about 20 to 30 minutes and check for proper functioning of system. Check current and temperature to be as specified. Check low side pressure to be within limits. During this period, it's a good servicing practice to check for leak on all high side joints of the system. Step 13. Sealing of process tubes. Switch off refrigerator. Detach from evacuation and charging unit. Pinch process tubes with a pinching plier. Remove process coupler or valve from tube ends. It's a good servicing practice to check for leak before sealing the tube ends. Seal tube ends using brazing torch and filler rod. Remove pinching plier and apply filler rod on the pinch area for strengthening. Check for leak after removing pinching plier. In case of system charged with hydrocarbon, as a safety measure, it is advised to pinch the process tube at 2 locations before brazing the tube ends. Fit drain pan on top of compressor.